One thing that you may have noticed is we've been giving a lot of examples of uh, algorithmic composition techniques that might generate some pretty interesting sounds on the small time scale. And we've given lots of short examples, and some of them are pretty nice. But how does that scale to something longer? You can't just take um, a rhythmic texture or a pitch texture and play that and let that run for 10 minutes and expect people to focus on it. I mean, you might want to do that. Everything is possible, and uh, there are some musics that are very drone-like or very repetitive, and composers sometimes choose to do that. But let's talk about ways to introduce variety in longer timescales. And I want to talk about tendency masks as a way to do that. So the problem, again, is algorithmic composition can lead to things that get very static. As soon as you figure out what's going on, even if there's probabilistic variety, your brain quickly accommodates to understanding what the distributions are, and nothing's a surprise anymore. So one thing that you can do to introduce global trends and global changes is manual change of parameters. And so the idea is given by this picture below in the slides, that imagine if I've got a couple of parameters, and time here goes from left to right, and what this top figure is saying is that the parameter value starts here, and as time progresses, the parameter is randomly chosen from between this lower bound and this upper bound. And so sometimes things get very, very random. There's a big range of choices. Other times the choices are narrowed down to something very specific. Then it expands again. There's an overall global trend. There are, smaller structural forms happening here. So all of this, can lead to a global shape in a piece that's very interesting. We can, of course, control multiple parameters. So here's another one down on the bottom that may or may not be coordinated with the one on top, and so on. All right, so that's in an abstract sense, that's what's going on. How can we actually implement something like this? Well, one thing that we can do is use envelopes in Nyquist. So imagine that we have something like a duration envelope created with PWLV and a bunch of parameters, and it might have a shape like we show in this diagram up here. And so here's some code, and specifically I want you to look at this comment. Here's how to access a signal at some point in time. We call sref, which is a new function. It stands for sound reference. So we're going to reference a sound, and remember, envelopes are sounds. They typically have low sample rates, but in Nyquist, they're all sounds. So we take this duration envelope and we access it at a certain point in time, which is SG start. What's SG start? Remember, the ScoreGen provides a number of parameters every iteration. So SG start is just the starting time of the note that we're currently constructing. So what we're saying here is that the inter-onset interval at this point in time is going to be taken from the envelope, and we're going to add a little bit of randomness to that, just for whatever reason. And let's play what this sounds like. You should be able to follow the duration by looking at this picture, which is graphing the envelope. Now, Nyquist also provides an envelope editor. This is actually copied from the Nyquist IDE. So this gives you a graphical editor where you can edit these long-term envelopes. You can incorporate them into your composition and especially into algorithmic composition. So we've looked at a lot of aspects of algorithmic composition. We've talked about score manipulation functions, some techniques like negative exponential and rhythm and timing. We've looked at probability distributions, random walk melodies, the idea that repetition of patterns can create recognizable rhythms even if they're very random. We talked about serialism and 12-tone music and atonal music, the use of tone rows, and we looked at quantization for scales and for beats as a way of kind of reintroducing structure into continuous random variables. And we just looked at tendency mask for long-term form. So you now have a lot of tools for generating music algorithmically and exploring all kinds of new sounds and forms and approaches to making music.